is Suresh, lecturer in ICE from Government Polytechnic, Vellampalli. I am going to teach the subject microcontroller programming, that is the C18 curriculum of Electronics and Instrumentation branch, 4th semester. Subject code is 402. Till now, we have learnt about the basics of 8051 microcontroller, that is block diagram of microcomputer, features of 8051, and the Intel IC chips, integrated family of chips. We have seen about the features of those earlier technology. And then we have moved on to the particular microcontroller, that is 8051, which is the core and important topic in this subject. In that, we have learnt about the register structure of 8051. What are the different types of registers we have? General purpose registers, special purpose registers, and then special function registers. Simply we can call special function registers as SFRs. In the SFR registers also we have number of SFRs, and in the last two video lessons we have successfully completed about the complete SFRs with their bit arrangements and for what purpose those registers are used in the 8051, what are the conditions. So we have learned about those topics till yesterday, and in the yesterday's class itself we have touched this topic. It is the pin diagram of 8051 microcontroller. I hope all of you have drawn this 8051 pin diagram completely in your notebook. I have given you this assignment. One must complete this diagram, completely draw with a neat sketch. And moving on to the topic, it is 8051 is packaged in a 40-pin dual inline package. It is important to note that many pins of 8051 are used for more than one function. The alternative functions of pins are shown in the parenthesis. The 16 pins are used for single function. The remaining 24 pins may be used for one of two entirely different functions as shown in the figure. And in the figure we have the pin diagram and the description of each pin. So this is the important part here. If you see the pin 1 to 8, pin number 1 to 8, 1 2 3 4 5 6 7 up to 8, so those are assigned to the port 1 port 1. So a total of 8 pins named as P 1.02 1.7 are belong to port 1. These pins can be used as input or output, so we can use these pins as input or output. In the earlier lectures we have defined these ports as IO pins. Port 0, port 1, port 2 and port 3 are. Port 3 has the pins which are IO pins, that means input or output pins. And the pin 9 is what? RST. In the diagram pin 9 is mentioned as RST, that is reset input. A logic 1, that is high, on this pin resets the entire microcontroller, the total microcontroller at any point of time. If it is under any circumstances, that means microcontroller is doing some mathematical operation or logic operation, some processing operation, or it is in ideal condition. Even in that condition also, if we send this high input, that is one input to this pin 9 reset pin, because RST we have written as RST, that means a logic high input should be activate this, that is it is active high pin. It is a active high pin. If it is RST bar, if it is RST bar, then it is a active low pins. Then we have to send a 0, that is low voltage signal. 0 has to be sent to this particular pin to reset the entire microcontroller. If you can remember, maybe in the real world you might have seen some of the electronic devices in which we have this particular button, reboot or reset button, or reprogram, that means to store the factory reset settings. So the name can be different, the names may be different, but a particular button will be there. Either it can be a software or a hardware particular button, physical button is there. If you press that button, generally it will be indicated in a red color, so that everybody can find it easily. So that reset button, if you press it, then the entire electronic device will reboot from the by default values will be stored in the registers or the flags which may be assigned to that particular device. Then we can reprogram it or maybe function. This can also be used when it malfunctions, that means a particular microcontroller or particular electronic device is malfunctioning, that we are not getting the particular output, though we have written a good code, correct code, we have given the inputs correctly, but due to some software function, if it is not giving the outputs correctly, then we can press this reset button to reset the entire microcontroller. So such a beautiful application is there for this reset input. By applying logic 0 to this pin, the program starts execution from the beginning. That means logic 0 to this pin, and the microcontroller will function smoothly, function its way. But if you apply logic 1, that is it will resets the microcontroller. Next, pin number 10 to pin number 17. Pin number 10 to pin number 17. If you see, it is a port 3, port 3.0 to port 3.7. And this is the important port because it has multiple functions, multiple values, or multiple pins, multiple functions are assigned to this particular port. In the yesterday's lesson, we have seen each and every pin of this port 3, what it will do, what each and every pin will be assigned. And in the diagram also you can see in the parenthesis, but in the brackets, the extra functions assigned to this particular port is visible to us. That is P3.0 has RXT, that is receive data, and P3.1 is TXT, that is transmit data. You might have thinking that why he is teaching slowly, or why he is repeating each and every point again and again. I have already stated that this is a basic microcontroller one must learn if you want to program it, and if you want to learn other complex and real world applications in this 21st century. This is the basic microcontroller. So the students who are listening to this class are from the 10th class, just they passed this 10th class and coming to the diploma level. This is the first time they are hearing about this microcontroller and these terminology and these pins or whatever the new words they are listening. They have to be habituated to these words. That's why I'm repeating these topics and the particular pins with their names again and again. So be patient and listen correctly. Okay. So P3.2 has ANT0 bar, timer interrupt 0 bar, and P3.3 is interrupt 1 bar, timer interrupt 1 bar. P3.4 is P0 timer 0. P.5 is T1 timer 1. P.6 is write bar. P.7 is read bar. So pin 10 to 17, that is port 3. Excuse me. Pin 10 to 17, that is port 3, is similar to port 1. Each of these pins can serve as general input or output. In addition, these lines provide alternate functions as listed in below table. The same table is listed here, but see the P3.0, that is pin number 10 RxD, that is serial data input. We are receiving the data serially from the external sources through this pin. And pin 3.1 is TXT, serial data output. That is, we are transmitting the data serially from this pin. And pin 3.2, that is INT0 bar, interrupt 0 bar, external interrupt 0, and that is a input. In this pin, the external interrupt is connected to this pin. The external interrupt 1 input, and the external interrupt pin 1 is connected to this particular pin. P3.4, that is T0, external timer 0 input or counter 0 clock input. And P3.5 is timer 1, external timer 1 input or counter 1 clock input. Yes, counter is also there. From the features topic of 8051, we can remember 8051 has 16-bit to 16-bit timers or counters. So same timers can be functioned as timer or counter, and we manually, that means select, user can select, that can be how the particular timer has to be behaved. That is the mode selection. The mode selection of the timer also be possible from the user end through the pins, mode selection pins M0 and M1. See, we have to recollect such type of data through in the coming lessons also. Then only we can link the topics and collectively understand the entire subject. Then the P3.6 is write bar, external memory write signal. We have to write the data to the external memory, so we can interface the external memory. How much amount of memory can be interfaced with this microcontroller? That is 64 kilobytes of external RAM or external ROM. So if we connect that external memory, if we configure or assign that particular external memory to 8051, then we have to use the signals write bar or read bar, that is port 3, 3.6 and 3.7 pins. To write into that memory from the 8051, we need to use 3.6, that is write bar signal, and to read from that external memory to this 8051 microcontroller, we will use port 3.7. It is port 3rd, pin 7. Next is pin 18 and 19. Pin 18 and 19, that is extal 2 and extal 1, that is oscillator signal. The 8051 has on-chip oscillator. On the chip itself, it is connected. On the chip itself, this 8051 has a oscillator, crystal oscillator circuit. Crystal oscillator, but it requires an external clock to run it. It requires the external clock. Most often, a quartz crystal oscillator is connected with these 2 pins. A quartz crystal oscillator is connected. If you can remember from the electronic device and circuits subject of 3rd SEM C18 curriculum of electronics and instrumentation branch, in that we have this topic oscillators. In that we have learned about this crystal oscillator. Quartz crystal is used to produce the waveforms, and the produced waveform frequency depends on the physical attributes of this crystal. And why we use such type of oscillator? Because of its high stability at higher frequencies. So this 8051 has a higher clock, that is around 12 megahertz. 12 megahertz of clock pulses we need to produce in order to function the 8051. So such type of higher frequencies has to be sustained without any distortion. Okay, so we need to produce such type of waveforms through this crystal oscillator, which will be connected to the 8051 through pin 18 and 19. If you decide to use a frequency, that is the second point I am reading in this slide. If you decide to use a frequency source other than a crystal oscillator, such as a TTL oscillator, it will be connected to extal 1 and extal 2 is left unconnected. That means there are 2 pins, right? Extal 1 and extal 2. In between those pins, we have to connect the crystal oscillator. That is 2 sides. 2 sides of the crystal is connected to these 2 pins. If you want to connect another oscillator, that is TTL, transistor logic oscillator. If you use the TTL oscillator, then only to extal 1 we will connect this oscillator, and to extal 2 is left unconnected. And the pin 20, that is VSS, that is this power supply is grounded. Ground supply is connected to pin 20, and pin 21 to pin 28, that is port 2. If there is no intention to use external memory, then these port pins are configured as general inputs or outputs. That is, we have in this diagram from pin 21 to 28, it is connected to port 2 pins P 2.02. In the brackets we have A8 to A15. That is external address, external higher byte address is connected to these pins. If you don't want to use this external address, that is, if we connect the external memory, then to access that external memory and to write into that external memory, we should connect these pins to that memory. If you don't want to use the external memory, if particular application is for a particular application, if it is sufficient, that is the on chip, that is 128 bytes of RAM and 4 kilobytes of ROM is sufficient, then we don't need to connect the external memory. In such case, these pins port 2.0 to 2.7 can be used as a normal IO pins only. In case of external memory is used, the higher address bus, that is higher address, will appear on this port A to a pin. And the pin 29, that is PSEN. PSEN, it is not ESPN, okay, it is PSEN. Program store enable is the active low output pin. PSEN bar, okay, the 29th pin is PSEN bar, that is the active low pin. That means if you have to give the input as 0, then only it will be get activated. Active low output pin. If external ROM is used for storing program, then a logic 0 appears on it every time the microcontroller reads a byte from the memory. That means if the external ROM is connected, then to store the program, the logic 0 appears on it every time microcontroller reads a byte from the memory. If the external ROM is connected to microcontroller, will do something with that RAM, that it will write the data or it will read the data. Then if we are reading the data from that particular memory, then a 0 will appear on this pin, PSEN bar pin. Next pin 30 is a ALE, address latch enable pin. Address latch enable is an active high output pin. ALE, it is also a output pin and it is an active high. It is used for demultiplexing the address and data bus. Demultiplexing the address and data bus. That means we have AD0 to some AD7, right? AD0 to AD7 on the port pin 32 to 39, that is port 0. AD means address and data bus. Both are connected, both are multiplexed on that particular bus. Then we have to demultiplex at the receiving end. Then we can separate them and use it efficiently. So for that particular demultiplexing, we will use this ALE pin. Address latch enable is an active high output pin. It is used for demultiplexing the address and data bus. The pin is also the program pulse input. Pin is also the program pulse input during the EEPROM programming. So EEPROM programming is separate topic and we don't have it in this syllabus. So particular that application, this pin will be used. Then pin 31, that is a EA, external access. External access is an active low input pin, that is EA bar. I hope it is a EA bar, pin 31. It is EA bar must be there because it's if it is active low pin, there is a EA bar. EA in the bracket we have VPP, right? So in the EA, it is an active low input pin. EA is equal 0, then the program code bytes can be fetched exclusively from the external ROM. That means in that case we use only the external memory, not the internal memory. Though we are using the internal memory, but the fetching of this program to execute the instructions whatever we have written on these programs, so those code will be fetched exclusively from this external memory only. That is from the address 0000H to FFFH. See, this range is 0 to FFFF. That means how much is the memory we have represented in this range? And the last we have FFFF, 4 ones. Each bit has 4 ones, total 16 ones. 16 ones. So we have 2 power 16, that is 2 power 10 into 2 power 6, 64 kilobytes. If EA is equal 1, program code from address 0000 to 0FFH is fetched from internal ROM. and remaining code where address is 100H2 www is from external ROM memory. That means if we use EA is equal to 1 pin, then the program code from address 0000 to 0FFF up to this point is fetched from internal ROM, and the remaining 1002 to the end www is from external RAM. So if we put EA is equal to 1, then the program will be shared program will be shared and fetched from this ROMs, internal and external ROMs. And the pin 32 to 39, that is port 0. So similar to port 2, if external memory is not used, these pin can be used as general inputs and outputs. In the diagram you can see that is port 0 is multiplexed, used for multiple functions. That means either input output pins and with AD0 to AD7, address and data 0 to address and data 7 pins. So if you don't use the external memory, then you don't need to use this AD0 to AD7, and we can use those pins to the input and output pins. Otherwise, this port provides low order address and data bus for external memory. And the last pin, that is pin 40, is VCC. V is capital and the CC is the subscript. And the subscripts we have to write CC. 8051 operates on DC power supply of plus 5 volts with respect to ground. The plus 5 is to be connected to pin VCC. Okay. And the additional information about this pin diagram, figure shows the pin diagram. The description of each pin is as follows. Power supply pins. Pin number 40 and 20 are used as power supply pins. Pin number 40 for plus 5 and pin number 20 is for ground. And this is the categorization of 8051 pin. So please draw this diagram. This is the categorization of 8051. We have specified the diagram. That means 8919 crystal oscillator XTAL1 to XTAL2. 40th pin is VCC, and reset pin is for 9, EA bar for 31, ESEN bar for 29, ALE for 30, ground for 20. And the remaining 32 pins, that means 8 ports we have, 4 ports and 8 pins, 4 into 8, 32 pins are represented to the right side, that as port pins. With the range of pins also mentioned, 1 to 8 and 10 to 17, 21 to 28 and 32 to 39. These are the IO ports as well as IO pins. Now the remaining 1, 2, 3, 4, 5, 6, 7 pins, and we can say simply say 8 pins. The crystal 1 and crystal 2. So 8 pins are total 32 plus 8, 40, right? 8 into 4, 32 plus 8 pins. 8 into 4, 32 plus 8 pins, that is 40 pins. This is the categorization of 8051 or simplified diagram, you can see. That is in the crystal pins, that is from this categorization of pins also, categorization of pins topic. First one is crystal pins. The 8051 has an on-chip oscillator, but it needs an external clock to activate it. A quartz crystal is connected between XTAL1 and XTAL2. These two pins are input pins. We have already learned in this previous topic only. And port pins, 8051 consists of 4 ports, and each port needs 8 pins. The ports are port 0, port 1, port 2 and port 3. The function of each port is given below. Port 0, that is pin number 32 to 39, is assigned to port 0. These pins are bidirectional pins. Yes, these are bidirectional pins. They can be used as both input and output, right? So we need to send the data from this pins and we have to receive the data. We can receive the data from the external source through these pins. So those are bidirectional pins. Port 0 is also the multiplex lower order address and data bus during the access to external port and data memory. This port needs pull-up resistors. That means we need to connect these pull-up resistors to these multiplexed signals, that is port 0 and we have port 2, right? So in those particular pins we have to connect this pull-up resistors. Port 1 requires 8 pins 1 to 8. It can be used for input or output. This port need not require pull-up resistors. Port 1 can be used only for input and output, so we don't need for this pull-up resistors. And pin number port 2 from 20 to 28 is assigned, can be used for input or output. This port does not require any pull-up resistor. Port is also used for higher orders address pins. Port 3 pin number 10 to 17 assigned to port 3. This can be used for input or output. Port 3 has the additional function of providing some external important signals such as P3.0 and P.1 are used for the RxD and TXD. These two pins are used for serial communication signals. Port 3.2 and pin 3.3 are used for external interrupts, that is INT0 and INT1. Pins 3.4 and 3.5 are used for timers T0 and T1. Finally, P3.6 and 3.7 are used to provide control signals read and write. Control signals read and write. Reset pin number 9 used as reset pin. It is an input pin. When this pin is active high, the controller resets and terminates all activities, and this is referred as power on reset. Power on reset. EA means external access. Pin number 31 assigned is an input pin, must be connected to either VCC or ground. If this pin is connected to VCC, the controller accesses the internal ROM. If the pin is connected to the ground, the controller accesses the external ROM. PSEN program store enable is an output pin. Pin number 29 pin is used to control the external memory connected to OE pin of the ROM. Why I am reading this topic in fast mode? Because we have already seen these topics in the previous slides only. In the ALE also we have seen. Now we are moving on to the internal memory organization in 8051. Please draw this diagram, draw this tree diagram. Everyone must draw this tree diagram. I am giving you about 2 minutes to draw this diagram. Internal memory organization in 8051. I hope everyone has completed this tree diagram. Now just read the blocks, That is, on the top we have memory organization in 8051. To the left we have internal memory or on-chip memory. In the features topic of 8051 we have seen this internal memory, that is data memory, that is RAM of 128 bytes, and the program memory, that is ROM of 4 kilobytes. And to the right side we have external memory or off-chip memory. It is data memory of RAM 64 kilobytes and program memory, that is ROM of 64 kilobytes. So how this memory is organized, that means what are the sections we have in this memory, we will see. A functioning computer must require memory for program and data. ROM is used for program and code, and data could be stored in RAM. Code memory is the memory that holds the actual program that is to be run. Data memory is the memory space where data are stored. 8051 has internal RAM and ROM memory for these functions. Additional memory can be added externally using suitable circuits. That is, any computer, any microcontroller, any microcomputer also, you need memory to run any program. Through any process also, you need to write certain instruction. That instruction must be stored. That instruction is nothing but the program code. So that has to be stored in that particular memory section of that particular microcontroller. So the program will be stored in the ROM and the data will be stored in the RAM. In the internal memory, that is on-chip memory, 8051 has 128 bytes of RAM for data memory and 4 kilobytes of ROM for code memory inside the IC chip. These memories are called internal memory or on-chip memory. So, and we have about 8 minutes or 7 minutes left still on this class. So instead of continuing this topic also, we quickly recap what we have learned in this particular session, then we can move on to the next topic in the tomorrow's video lesson. Just quickly recollect whatever we have learned. This is yesterday's topic, that is special function registers, addresses, and registers names also. The star mark indicates they are bit addressable. Right? You remember, right? Before we have learned about port 3 ports, TMOD, TCON, PCON, power control, use it to control for power control and baud rate selection. So these already we have seen, but in today we have learnt about the pin diagram. Totally 40 pins. To the left side we have port 1 and port 3. You can remember left as odd numbers and right side even number, port 0 and port 2. Like that you can remember. And to the right side we have over multiplexed signals. Port 0 is AD0 to AD7 and port 2.0 to 2.7. See, these are arrangements. If you see port 0 from top to bottom we have from port 0.0 to 7, but in the port 2 we have bottom to top we have 0 to 7. So that is a little bit tricky type. So you have to draw this diagram by looking at the diagram once or twice, and by lot looking, that is just remembering the diagram at least 3 times, at least minimum 3 times, then only you can easily grasp this diagram and you can remember each and every pin. First time you may lose some of the pins from your memory, but don't worry, the next time you will collect whatever the missing pins you don't remember, then you will recollect it and read it again and remember it. So that's why we have to draw these diagrams again and again. It may take 5 to 10 minutes more, but if it comes in the exam for 10 marks or 15 marks, there you can draw this diagram within short time. In order to for score more marks, if you draw this complete diagram, then the examiner we may give full marks to this diagram only. Like you write 4 to 5 lines to or about the particular pins. But if the diagram is beautiful and correctly drawn by mentioning each and every pin, then he will be impressed easily. He or she will be impressed and can give the full marks, even full marks to that particular answer. So the practice makes you perfect. If you don't practice, then you may not remember all the pins. But whatever the pins you remember, let us say at least 30 pins you remember now, but during the exam you may recollect only 10 pins. Then you draw the 10 pins only. Then the examiner will think that he didn't practice the pin diagram. He just remember whatever he drawn. So he may give lesser marks. So that should not happen, right? You should work hard and smart both. So in this particular time, that is during the first chapter only, you having plenty of time and fresh mind towards this subject. So you need to practice each and every diagram twice or thrice minimum, or conduct a slip test by yourself. Just take this question only, draw the pin diagram and explain each pin, and put a time limit of 15 minutes. Then assess yourself that whether you have drawn the complete diagram and explain about each pin, and you complete the answer within that particular 15 minutes or not. If you cannot, then how can you complete the same task in the examination, where end examination, where you have to remember the entire 6 chapters, different topics, different answers. So at that time it will be very difficult for you. So practice at home perfectly to score good marks and to learn the subject and for further knowledge also. So remembering the each pins, that is pin 1 to 8 we have belonging to port 1. These are IO pins, and for the reset pins it will reset the microcontroller logic 5. So one has to begin and port pin 10 to the 17, port 3. Each pin serves a general input, and additionally there is some alternative functions. This is the table rxtt xti int0 bar int1 t0 t1 write bar and read bar, and external 1 and external 2. Crystal is connected to crystal oscillator connected to these pins towards the clock signal. If it is not crystal, then we will use the TTL, that is C TTL oscillator, then we can use only the external one pin only. Then is VSS power supply ground, and 21 to 28 we have port 2. Port 2 also has several other functions, that is higher order address bus A8 to A15 will appear, and PSE and program store enable, and the external ROM is used for storing program. Then logic 0 appears every time the microcontroller reads a byte from memory. So these particular pins separate pins PSEN, ALE and EABR. These are different from this port 0, port 1 and port 2, port 3. So in the examination also, the examiner can ask this particular pin, explain about PSEN, explain about ALE pin of the 8051 in the 2 marks session or 3 marks part also, and we can expect this type of questions in the competitive exams also. Yes, each and every pin they can ask in the short answer questions also. EA means external access is an active low input. EA0 program code bytes can be fetched from exclusively that is external memory, and EA1 a portion will be set fetched from internal ROM, that is 0000 to 0FF, and remaining 1000 to FFFF from external memory. This internal memory address, if you see the range 0000 means 0 bytes to 0FF, that means 12 ones, 4 plus 4 plus 4. 12 ones means 2 power 2 into 2 power 10, 4 kilobytes. That is the internal ROM range, 4 kilobytes, 0 to 4 kilobytes, and 1000 to FFFF up to 64 kilobytes from the external ROM. The range also has to be matched with the feature. The pin 32 to 39, that is port 0, and VCC for the power supply, and we have seen the categorization, simplified version of the 8051. So with this we conclude today's session. In the tomorrow we will see this topic, internal memory organization in 8051. Thank you one and all. If you have any doubts, please mail me at sureshakul2001 @gmail.com.